So it's possible that everybody on Facebook Live is going to see this before our Zoom participants, but I wanted to say welcome. I'm Justine Labello. I'm the marketing manager for Bluebird. There is a 20-second delay between the Zoom call and the Facebook Live version. So if you submit a question and it doesn't get asked right away, that is likely why. I do encourage you to type your questions in the chat box on Facebook Live while we're doing this. And we'll be putting those questions out to Hinton Harrison, who is our EV expert here at Bluebird. So we will get started here in a minute. I'm going to let everybody into the meeting room, and we'll get started momentarily. Hello, everyone, and welcome to our live virtual ride and drive with Bluebird and our expert EV panelist, Hinton Harrison. I'm Justine Labello, the marketing manager for Bluebird. We are also broadcasting this to Facebook Live. I want to reiterate that there is a 20-second delay between the Zoom meeting and the Facebook Live video that everybody might be seeing right now. So if you have a question, if you're on Zoom, you can actually send your questions to the host through the chat box. That's going to be on the lower right-hand side of your screen on Zoom. If you're on mobile, there should be a little option on there as well. So just send your questions to the host and we will get them to Hinton during our Q&A session. And if you're on Facebook, you can also ask your questions on the chat box or just make a comment. And that will get directed to me and I'll get that to Hinton at the end of the panel during our Q&A. And of course, if your question does not get answered during our Q&A session, you can always contact us after the meeting. We will provide that contact information to you as well. So without further ado, I'm going to go ahead and start the drive portion of this, this meeting, and then we will get to our Q&A.
Hi, I'm Hinton Harrison from Bluebird, and behind me is our all-electric conventional electric bus. Today we're going to go through how to start an electric bus and go through some of the interior features of that bus. One key point of an electric bus is how quiet it is, to the point where it's almost too quiet. But one of the features that I wanted to point out to you before we do that start is in our front grille, we have what's called a noise generator. And this noise generator turns itself on and off depending on what the bus is doing. So for example, when the bus is sitting still or it's doing less than 18 miles an hour, the noise generator emits a sound that's loud enough for the people at the bus stops or on sidewalks to hear the bus coming. Once the bus reaches a speed over 18 miles an hour, it slowly turns itself off to where you're not hearing that noise going any faster than that. So now let's go inside and start the bus. Now to start an electric bus, it's a little bit different than if you have a diesel or a propane engine. So that's what we're going to go over right now. So the first thing you want to do is get your seat adjusted, get your steering wheel adjusted, and you also have to put on your seat belt. That's one of the two interlocks that must be met in order for the bus in order to move down the road. In order to get it started, first turn the key to the on position. And what that will do is that starts to energize and start the systems activating. And what you want to look for is where it says in your display, initialization complete. Once you see that, go back to the key and give it about a 1 to 2 second turn and release it. You'll now see where it says vehicle enabled, And now the bus is ready to go, but almost. The second interlock we have to satisfy is we have to close the entrance door. If the entrance door is not closed and your seat belt is not on, we will not be able to put the gear selector in either drive or reverse. So to prepare to move down the road, you want to put your foot on the brake, release the parking brake, and either push D for drive or R for reverse. Now, if we did not have our seat belt on or the entrance door was closed, and I'll demonstrate that here, we get a warning signal on our cluster that tells us to set the parking brake because we do not have our seat belt on. If I set the parking brake, that signal goes away. But I still cannot go back and try to move the bus, nor will it go into any gear. If I put my seat belt back on, release my parking brake, I can go to drive, or I can go to reverse, or back to neutral. So one of the first things you'll notice when you're driving the electric bus is just how quiet it is. You hear a little bit of road noise from the tires. You hear a little bit of a rattle as you're hitting a few of the bumps. But that's one of the nice things about this, is now you can concentrate on the road and also the passengers. The other thing we need to point out is we have replaced the tachometer on the electric bus with an efficiency meter. So we want to try to keep that meter as close to the green and the amber as possible. When we get a little heavy-footed with the accelerator, notice we get it to a very inefficient range. We want to stay in this range as much as possible, and also, as we're speeding up, we want to coast into our stops as much as possible, which allows the motor to turn into a generator that puts electricity back into the batteries that extends our range. We're going to make a turn up here in about a quarter of a mile, and I'll show you what I mean about how the motor will turn into a generator, because right now we're burning about an average amount of electricity, and then we want to coast as much as possible, and we'll watch that meter come into the green. So right now I'm coasting. The meter has come over into the green, and our regeneration is also acting like a secondary brake. Sort of like a retarder or a VGT on a diesel bus. Now again, I'm going to make a demonstration on how not to drive it. It makes it very inefficient, and it also reduces your miles. Notice my gauge is very much into the amber range. It's fun to drive, but it's inefficient. This is where we like to have the meter be when we're driving down the road. So if we're in the back roads or you're in a hilly area, you're not going to want to drive this bus too much different than what you drive your other diesel or propane buses. This bus, once you drive it the first time, you'll notice it has a lot of power. So you getting up the hills are going to be a lot easier with this bus. You're going to move pretty well. It's going to be able to pull out in traffic really well, especially if you have to pull uphill. It's a little difficult to show here just talking about it. It's definitely something that you must experience in order to get the full effect out of it. And we're going to show here that I'm approaching this intersection. Notice I'm coasting as much as possible, very light on the brakes. And we're going to go around this turn. What we're going to do is we're going to show that we want to accelerate very slowly. We want to keep our gauge pointed up just about as much as possible. So yes, it is a little bit slow, but we're trying to save the batteries and extend the range as much as we possibly can. A lot of people ask, well, why should I pick a Bluebird electric bus? And there are a couple reasons for that. One, it's the Bluebird name. We've been around for years. We were the first with electric buses back in 1994. And when we built this bus and we put an electric motor in it, we did not sacrifice any of the safety features that all of the Bluebirds have. So the body that this bus has is the exact same body that all of our Bluebirds have. It meets the Kentucky pole test. It meets the Colorado racking test. So we wanted to make sure that everybody understood that even though it doesn't have an engine in it, it's still the exact same body, the exact same seats, with the exact same safety features as all of our other Bluebird buses. So a lot of people, when they first drive this bus, they're a little hesitant to pull out into heavy traffic, or they're afraid that the bus is not going to move very well. But when they get in it and they actually get behind the wheel and they drive with it, then they understand that this bus actually has more acceleration and more power to start with than what the diesels and the propanes do. So sitting here checking the mileage and looking at the bus and how we did with it today, we took a note of that we drove 16 road miles today. But our batteries saw that we only used 11 miles worth of electricity out of them. And all that is because of our regeneration process on this bus. So while the bus is coasting and you don't have your foot on the accelerator, the motor that pushes the bus down the road turns into a generator. And that generator makes electricity and puts it back into the batteries to be consumed a little bit later. So all that electricity that we can make with the motor while on route, that if we drive really slow, we don't take off too quickly, and we keep our top speeds down, we can put quite a bit of electricity back into our batteries for a very efficient style electric bus. Thank you for joining us today on our Bluebird all-electric ride and drive. If you'd like more information, please go to our website at www.blue-bird.com.
Hey, Hinton, how's it going?
Well, hey, good morning, everyone.
So we are going to go ahead and start with our Q&A. I have quite a few questions already for you, Hinton. One question that was actually submitted to me prior to the Q&A was talking about the connectivity of the electric bus to the cloud, locations and reporting. Can you speak to that?
Well, yes, we have that. It's part of the telematics package that we get from Cummins. It will tell you, in fact, we have a couple seats of that in Macon, and Cummins also has it, where we can actually track in live time, real time, where the buses are, how they're moving down the road, how fast they're moving, and where they are in real time. So yes, we can do that. We can report that type of information out to the customers. We are still in process of working out a package that we can get to the dealers and the end users. We're just not there yet with that. But yes, the telematics will tell us exactly where the buses are and what they're doing.
Excellent. Hinton, can you hear me okay, by the way? Is my audio coming through?
Yes.
Awesome.
Yes,
okay, great.
Yes, this
just
portion is working really well.
Wonderful. So another question that I had is about performance in colder climates, and especially I've got a couple questions about salt on the buses. How does that affect an electric bus?
Well, it's not so much the salt that we have seen causing trouble in the electrical components. They're all IP rated to handle that type of environment. What we're more so seeing is that when people are trying to clean the bus, they're getting a little overzealous with their power washers. And what they're doing is they're taking the power washers and they're going up underneath the bus and around the bus and putting a little too much pressure and a little too much water into the numerous connections that are around the bus. When you have electricity, you have a lot of connections, you have a lot of wires that have got to come together, and that's where we're seeing some of the issues. We see more issues with salt on the brake components and the wheel end components than what we're seeing with the electrical components. So not so much a problem in the winter with the salts, just more so with the washing. Even down in the warm climates where people are washing their bus with the power washers, we've had to do some troubleshooting because of some water getting where it shouldn't be because of a couple thousand pounds of pressure coming out of those nozzles. But salt-wise, road-wise, corrosion-wise, no, we're not seeing issues with that at this time.
That's great. Hinton, do you know how many EV buses are currently running in North America at this time?
I think we have about 150 approximately on the road right now, spread out through, I think it's 14 states, all the way, I mean, from California to South Dakota, up into New England. We just sold some. We have 4 on Long Island. So we have a couple down in Texas, 1 in Alabama. So we have them spread out all over the United States and in multiple types of climates these buses are operating in. And
that is just Bluebirds. I believe in all, there are hundreds of electric school buses out there, some from different operators, but that's great.
Yes, I mean, I'd like to think we were the only one out there, but no, we're not. We have 3 other competitors that we have to bid against. So there are a lot of electric vehicles out there. We are not the only one. So it's new technology, but it's not overly new, and we have to compete for what it is. It's not a given anymore.
Right. Someone mentioned that they'd like to look at the drivetrain of the bus. We're actually going to have a chassis walk around in a few weeks. So we'll definitely look at that in greater detail. Someone asked how long the batteries tend to last.
Yeah, okay. So tend to last, you mean tend to last like on a route or in a lifetime of the bus? But
I'm going to assume they mean lifetime.
Okay, so we're estimating that these batteries are going to have a life of about 8 to 10 years as a school bus. Now, we have to be careful with that, and not at 10 years and 1 day is the bus all of a sudden going to just stop moving. It's very similar to what your battery is on your iPhone. So when you bought it brand new, you had good performance. The phone would last at least a day, if not a day and a half. And then over time, the phone just it won't charge up all the way, and it doesn't last as long as it used to. Well, that's the same way with this bus. What we're saying is in about 8 to 10 years, the bus will still be able to charge itself up to about an 80% capacity. So it's still useful. You can still use it. It just, your range will come down because you'll only get about 80% out of it. Now, that's just a guesstimate right now. We've had these buses out on the road for about 2 years, and we have not seen any substantial degradation in the batteries yet. So those, excuse me, those that bought 2 years ago are not seeing any degradation that we know of just yet. And even when we're watching the telematics, we're not seeing any substantial fall off from the batteries. So in short, we're looking at about 8 to 10 years right now is what we're saying is the life of the batteries.
That's great. And then someone is asking about V2G. We will actually have a webinar on V2G at the end of the month, so watch out for that. But we could probably ask this question is, how does vehicle to grid affect the battery life?
The batteries are rated for a certain amount of throughput. And what that means is how much electricity goes into the batteries and then comes back out of the batteries. And the batteries actually do not mind being discharged like that. In fact, it's actually good to cycle the batteries like that. So what we're seeing is in the typical life of the bus, that if you do use the bus in a V to G situation and you still use the bus as a school bus type vehicle, we're not seeing or we're not predicting any type of battery harm with the batteries that we're using. In fact, these batteries are set up for quite a bit more V to G that our bus right now can handle where we're at. I mean, we're working on higher rates of throughput than what we have right now, but right now our batteries would not see any type of harmful effects from having the bus sit over the summer, sitting over a holiday, and just cycling the electricity in and out of them.
Great. How does the air build for the door and the brakes?
So since we don't have an engine that has a compressor mounted right to that engine that would run all the time when the engine does, we have a separate air compressor that's run off of a separate 380 volt AC motor. And that motor is hooked on to a twin cylinder air compressor, and it's run with the same governor that all the other Bluebird buses have with air brakes. So what it does is that governor senses the pressure in the two reservoirs, which is the same reservoirs as all the other buses have. And when that pressure gets down to right around 80, 85 pounds, there's a micro switch that's closed. And that switch then sends a signal to that motor and it turns the compressor on. The compressor builds up its pressure up to about like 115, 120 pounds, sends that signal to the governor, and then the governor turns off the micro switch, and then the compressor stops turning. So that motor that's running the air compressor only runs when the air pressure drops and in order to build it back up. And we do that because there's no need to have it spinning all the time, because we'd rather conserve that electricity and keep it for pushing you down the road to extend your range, as opposed to just running a compressor all the time.
So someone's asking about rollback on the bus. Can you talk about that a little bit?
Okay, so there is a built-in rollback feature on the bus, so that if you're on an incline, let's say we're going up the hill and our gear selector is in drive, the way that would work is that you don't have to double foot it, as in you put your left foot on the brake and have your right foot ready to go on the accelerator. If you're sitting on the hill and then you press your brake treadle a little bit harder than what you normally would, what that does is that activates the rollback system to say, okay, yes, the brakes have been depressed adequately hard. And then depending on how steep of a grade you are, you may roll back about 12 inches, and then the motor torques up and keeps the bus from rolling back any further for about 5 seconds. So it's actually the motor that's turning to keep the bus from rolling backwards, and it's not the brakes that are doing it. Now, at the end of 5 seconds, that motor is going to let itself go, and then the bus will roll freely if that's what you wanted it to do. But you can reset it by just stepping firmly again on the brake treadle, and then it will move about 12 inches, and then it will hold itself.
Excellent. Someone's asking about the investment for infrastructure on these school buses. Can you speak to that?
Well, there are two different types of infrastructures that are available with this bus. We have a lower cost infrastructure in which you could have a level 2 charging that would get you to right around 19.2 kilowatts an hour. Those chargers, or what it's officially called, is an EVSE, the electric vehicle supply equipment. They run anywhere, and depending on the brand that you pick, could be somewhere between $2,000 and $4,000. And those will plug into a 240 volt 80 amp plug. It can use a 50 amp plug, which is very similar to what your regular maintenance shops have for your welders, and it will charge at about 12 kilowatts. But what we ask is, if you're going to go that route, that you have a dedicated line to have at least 80 amps of 240 volts. And you would work with your energy supplier to come in and set that up for you. So we cannot guesstimate what that is. All we can do is just tell you that the equipment to get the electricity from that would be about $2,000 to $4,000. Now, if you're going to go with DC fast charging, or as also you'll hear us talk about it, DCFC, that takes quite a bit more electricity. It takes quite a bit more equipment on the ground. And that, depending on where you are in the country and what you're working with, that equipment can run anywhere from $40,000 to $70,000. And that you would work with right directly through your dealer. You wouldn't work through Bluebird. And we could give you some suggestions. We can help you get a site evaluation to see if where you want to park the bus has that type of electricity available, and get you some estimated costs in order to get the electricity to where you want to charge that bus. And then you would work with your dealer and your local energy provider in order to go from there.
Excellent. So the next question is about how the bus is capable of vehicle to grid. And I think you should probably just talk about like our charging system that we have now on our buses.
Okay. So we have the two charging systems. And the nice thing about the Bluebird bus is that all of our buses come standard now that they can accept either level 2 or level 3. The customer doesn't have to pick. In fact, you can use them both, just not at the same time. And what we say both is, for example, if the bus had to go to a maintenance shop and it only had a small level 2 charger, it could charge there overnight. And then when it gets back to its normal charging station, through the same plug, and we now use what's called a CCS1, a combined charging system. Through that same plug, it can also DC fast charge at 60 kilowatts an hour. So you can do both. I think we're one of the few that can handle both right now, and it's standard equipment on all Bluebirds now. As of this month, it was standard. We changed plugs, so you can, if a customer just doesn't have the funds, they can go with the lower charging rate, and if they want to in a year, they can convert to DC fast charge at their infrastructure and use the exact same plug. There's nothing they have to change on the bus to go from a level 2 to a level 3 style charging.
Right. And the question, I can probably answer this one. It is DC fast charge that uses vehicle to grid, correct?
Yes. If you're going to do any type of vehicle to grid, we are set up to do it at 60 kilowatts, both coming into the bus and going back out of the bus into the grid.
Excellent. And what kind of batteries do we use is another question that we had.
We use Exalt batteries. They are that we get them out of a supplier in Michigan, and then they go to the Cummins place in Indiana, where they actually put those batteries together. They balance the batteries, and then they put them together in the modules for us. So if you want to get a little more information, it's the Exalt 111 Expand Pack. And you can get all kinds of information about energy density, the weights, the voltage. The voltage each battery has is 88 volts, but all strung together, our bus operates at a nominal 620 volts. One of the reasons we picked on that, and we'll get just a tad bit off subject here, but the reason we picked one of the higher voltages is that when you have that higher voltage, that is what helps accelerate you down the road. At 33,000 pounds, you need to be able to move this vehicle, and with those higher voltages, that's what's able to move the buses.
Excellent, excellent. And then someone's asking, how many miles can the bus travel on a single charge?
Well, that's like saying how many miles per gallon a vehicle can get. And if you look at the decal on the window, you get one number, and then when you actually drive it, you'll get something different. So what we've seen in real practical usage as a school bus, our buses are seeing somewhere in the middle 80s to low 90s on a school bus route. Now, what that's going to affect is how, we'll just say, how well does the driver like to use the accelerator on our buses? These buses are fun to drive. When you push that accelerator, that bus goes. And if you have a little too much fun with the bus, you're going to notice your range is going to suffer because of it. What we also have noticed is that if you have a bus, say, that's in the plains of Kansas and Nebraska, you're going to get better economy from that than if you're in the mountains in Utah or Wyoming. We've also seen the weather greatly affect it. The buses that we have on Long Island kind of suffer a little bit because of they're having to run their heaters, just like the one in Fargo. They have to run their heaters quite a bit more. And the only place that we get heat on this bus is from the batteries. And when we take the electricity from those batteries and put it into heat, it makes the range suffer a little bit. So in those conditions, what we were seeing ranges down into the 60s because they were running their heaters constantly. When we go into the warmer climates that are running the air conditioners more, the range does not suffer as much. We'll see that down into the upper 70s when they're running the air conditioners, because it doesn't take as much electricity to cool a space as it does to heat it. So if we're going to just run the bus without any HVAC on it, and we're going to be very judicious with our accelerators, and we're going to use regeneration as much as we possibly can. We have 3 or 4 customers out there that are getting well over 100 miles because they kind of turned it into a contest between the drivers. And we have some, and we can see that on the telematics, that they're averaging between 100 and 110 miles on their route just because they're using the regeneration so well.
Excellent. Well, we are out of time now, but I really appreciate everybody's questions, and we will be posting the video on Facebook and sending it to all of the Zoom participants after this call. If you have any other questions, please feel free to contact us. You can email us at marketing@blue-bird.com, and we'll get your questions over to Hinton. And thank you guys so much for your participation today. Make sure to tune into our other Alternative Power Month events that we have going on. Next week, we're going to do a walk around of a propane bus. And the week after that, we're going to bring Hinton back to do a walk around of the chassis of an electric bus, that you guys can really get deep into the inner workings of the bus. I know he's answered a lot of those questions today, but we're going to go farther into it in a couple of weeks. So I really appreciate everybody's participation today, and I hope you have a great day. Thanks, Hinton.
Okay. You're welcome.
Bye.
Have a nice day.